Okay, so I'm going to compute the limit of this rational function as x goes to infinity. What that means is that if this tends to a limit, then the rational function has a horizontal asymptote at that value. The way that I'm going to do this is I'm going to multiply by 1 in a smart way. And one of the smart ways you can multiply by 1 is by doing it so that powers of x cancel. So I'm going to look at what is the largest power in this rational function, and it's a cube on both the top and the bottom. And so I'm going to multiply both the top and the bottom by 1 over x cubed over 1 over x cubed. So multiplying by 1 over x cubed on both the top and the bottom, which means I'm multiplying by 1. So I'm not changing the limit. Right? So if I multiply everything by 1, I'm not changing the limit at all. But now I can distribute and see that this is going to help me cancel out powers of x. So this is limit as x goes to infinity, and I'm going to distribute the 1 over x cubed into both the numerator and denominator. So I get 5x cubed over x cubed plus 7x over x cubed plus 10 over x cubed, and the whole thing divided by negative 2x cubed over x cubed, x squared over x cubed, and minus 1 over x cubed. And so this is the limit as x goes to infinity. So now I get 5 there, plus 7 over x squared, plus 10 over x cubed, divided by negative 2, plus 1 over x minus 1 over x cubed. And now, as x goes to infinity, okay, the 5 and the negative 2 are constant, so we don't have to do anything with those. But as x goes to infinity, all the other terms are going to 0, right? I'm taking a finite number and I'm dividing by a power of x, and x is going to infinity. So I'm taking a finite number and dividing by something tending to infinity. So this goes to 0, this goes to 0, this goes to 0, and this goes to 0. All these terms go to 0. So most of the terms cancel in this fraction. So this is the limit as x goes to infinity of 5 over negative 2. All the other terms are going to 0. And now this 5 over negative 2, that's just a constant, right? So as x goes to infinity, it doesn't change at all. And so this is just negative 5/2. And so this says that this function has a horizontal asymptote at negative 5/2 as x is going to infinity.